Welcome to the first part of Competency 9 quiz questions. In this video, we will answer questions relating to trig functions. Number 1, which one of the following angles in standard position has a reference angle of 23 degrees? Okay, in this situation, because it's 23, we only have two choices. Okay, that means we have 23 going this way. Well, in this case, our reference angle and our standard position angle would be the same. It would be 23. Then our only other option then is to take 360 and subtract the 23 degrees, okay? So 360 minus the 23, okay, that gives us option D. Well, that means that the angle goes this way, okay? All right. So that would be our actual reference angle, and then the blue would be the 337 degrees, our position angle, okay? Those were our only two choices, so that had to be it. Okay, so let's move on to number 2. Point Q is located in a quadrant in which both the tangent ratio and the cosine ratio are negative, okay? So that's going to give us, well, for the tangent, we have two choices. We have Q2 or Q4. Well, cosine is positive in Q4, so that gives us one choice. That gives us Q2. Okay, well, then if we have Q2, that would give us a negative X value and a positive Y. I mean, that's all that there is. And so if we go and look very quickly, now you might say, well, what about C? Well, really, C is a 0, and that would not be appropriate. Okay, if you think about it, it really isn't. If we had 0, -2 and 0, we're not even in the quadrant technically. Okay, so that's like a little technicality. So it is option A. Okay, all right, let's go to number 3. All right, now if secant theta equals negative 1.2 and theta lies in the third quadrant, what is the value of cotangent theta? Okay, the first thing we're going to do, okay, is we're going to take that negative 1.2. Our calculator is going to cut us to what, let's just say it's going to cut off some worry and time and mental frustration. So I'm going to put in negative 1.2 and I'm going to push enter. Okay, you're like, well, what good did that do you? Well, it did me this. Now I can say math and I can enter twice, and that gives me a good fraction. Okay, and you'll see what that fraction is going to do for me. Okay, so I'm going to say negative 1.2 equals. Now I have 6/5. Who does that negative go with? We're saying quadrant 2 and secant. Okay, and we know that secant theta equals 1 over cosine theta. If you're in quadrant 3, cosine is associated with the x and it is negative. Okay? So, and that secant is 1 over cosine. Let's see, then that would mean we would have, that would mean that this is 6/-5. Well, now how did I get that? Okay. Well, let's rewrite this. What we have here is 1 over, and cosine is x over the radius. And that equals, okay, if you're going to have to use a reciprocal of radius over the x. So 6 is the radius, and 5 would be that x value, okay? Now let's draw our quadrant really quick right here. Okay, we're talking quadrant 3. So this is really what we have, the -5 and the 6. So in order to deal with our value of our cotangent theta, we need because cotangent, if you remember, cotangent is 1 over tangent, and then tangent is sine over cosine, which is also y over x, but if it's cotangent, it's flipped. So then that would be x over y. I know it's getting confusing, but we know either way, no matter how confusing it is, we need the value y. It is what it is. We need our y. So now we need that y value. So y equals, and look at our little triangle here, under the square root, 6 squared minus 5. So then that gives us, okay, and I'm going to leave it the value and not do the decimal quite yet. It's best to get your decimal value at the end. Okay, so really what we need here is 6 squared. We know it's 36 minus, okay, I'm going to go through the motions here. Okay, minus, parentheses, -5, and then close my parentheses, but I'm going to square that and now push enter, and I have 11. Okay. So we know that this is the square root of 11. Okay. So what do we need here? We need cotangent. Okay. So cotangent theta equals, that would be, cotangent is the negative x, or the x over y, which is -5, over square root of 11. Oh, I say it, then I write it wrong. Oh my goodness gracious. Jumping way ahead of myself there. Okay, not good. Okay, so we have -5 over the square root of 11. Okay, so let me clarify something. How do I know that for sure? Well, I know that cotangent theta equals 1 over tangent theta. And I know tangent theta, tangent is y over x, which tells me we need to use that reciprocal, which would be x over y. Okay. All right. And I kind of said that earlier, but I didn't write it down. So that's all we have to put in our calculator is -5 divided by secant, grab your radical, 11, push enter, and that's our value. Okay. However, there's one mistake being made here. That's in quadrant 3. Be careful, because a negative and a negative is positive, and that's misleading. That is a negative uh, 11 under the square root. So always go back and double check. Look at what quadrant you're in and note that cotangent and tangent are positive in quadrants 1 and quadrants 3. Okay, so immediately I knew that the negative values weren't going to work. It had to be one of the positives. Okay, and that's kind of how I clued myself in when I saw that answer value. Okay, always go back and double check your picture and then go back and look at your calculations. Okay, let's move on to number 4. Look at the diagram below. Okay, it's another triangle situation. If secant theta is equal to negative 0.75. Which one of the following represents the coordinates of point R? Okay, that's simple to deal with. Of course, on the last one, it was harder to see what the fraction is, but here we are going to do the exact same thing that we did before. So let's do that. Put your value of secant in the calculator, okay? So I'm going to say negative 0.75. Well, I already know that that's 3/4, but I'm just showing you the little trick we did, okay? So I entered it, and there it is. Now what do? I push math. It's highlighted on fraction, push enter, enter again. It gives me that 3/4. Now it's our decision to look at what we need. Well, obviously, they're giving us the third quadrant again, and that means that we have the same situation. So let me write this out. So negative 0.75 equals the 3/4. Okay. Well, what does that mean? Just exactly what we had earlier. Secant theta equals 1 over tangent, right? And that is, not tangent, I'm so sorry, is cosine, 1 over cosine. So cosine x is x over r. Well, that gives us r over x. So what do we know? We know that 3 is the radius and 4 is our x value, so 4 has to be the negative. So minus 4, and then this 3 would be the r. However, this looks like 3 times 10. Okay, so this is what I need you to do. Wrap your head around the fact that we're not going to go with that 30. We're going with the simplified form. Because let's think about it. If we took 30 over 40, we would end up with a 3/4. Okay. All right. So you just kind of have to go with that. It's how the size of the triangle and how you work with a triangle. That's pretty much what it boils down to. Okay. So we know that that is -4. Okay. Well, if we have -4, all right, first off, we're just going to kind of circle this, let it hang out, okay? Now, C was going to be the option if that's the case. And I tend to believe it, but you got to prove it to yourself by getting this negative y value here, okay? So how do we do that? Well, we just put it under the radical, okay? All right, so y equals under the square root 30 squared minus 4 squared. Okay. Well, oh, you know what? I'm looking at decimal form, so I don't even need to leave it under the radical. If you remember in the prior problem, I said, well, let's leave it the whole number value under the radical, worry about the decimal at the end. We're not doing that here. We need the actual decimal values. Let's just put that in the calculator. Okay. So second radical 30 squared minus, in parentheses, -4. Close your parentheses. Now square it, push enter, and that's your value. But what did I say? We need the negative form of that. Okay. So that means that's going to be a negative value. Okay. All right. Remember, that was something you just have to know to keep up with. And that being said, and you round it off, and that's correct. So it tells you these are close, but not quite it. Okay. All right. So let's go to number 5. Okay. Number 5. Okay. Number 5 is just a matter of knowing your values of sine, cosine, so on. All right. So let m and n represent positive real numbers if the inverse of sine is m, the angle, the inverse sine angle or value, m over n, the ratio. is not defined, NDE not defined, or does not exist. That's what I want to say. What conclusion is certain concerning the values of M and N? Okay, you know what? In this, you can think it out by looking at the triangle, okay, and looking at with what we're working with. Think about it. Sine is actually, okay, sine, let's say sine of x. We know that that is y over r, okay? In order for that to be a valid triangle, the radius must always be larger, okay? It must always be greater than that leg y. It has to be. Because if it was shorter, because we're talking right triangle, if it was shorter, would we have a right triangle? By the definition, the mere definition. So what does that tell us? Okay, that we have M, we have N. So we really have to think it out. So R must be greater. Okay, so what do we have? So if we call this M and this N, we are saying for this to be valid, N must always be greater than M, or M is less than N. Okay, well, this means this is valid. We want one that is not valid. Well, I'm saying that would be D. And then if you look at your other values, these are greater than 1. Well, let's say they're whole numbers. Then what I just said here still stands true. So this would still be true. It would not be undefined or non-existent. Now let's look at C. Okay, let's say because it's between 0 and 1, that would be fractions. Well, you would have to use reciprocals of fractions. You could still have, and you would still have this setup as being true. Okay, because then you would say, let's say P over Q, and then you would end up dividing N. This would be M, and then you would have N. Let's say they were A and B, okay, A and B, okay. Then you would start as you divide using the reciprocal, and that would still be defined. You know what? You almost have to stop the video and use some values that are reasonable and start playing with it on your own. And this is what I did. I said that M was 4 and N was 3. Okay. And that would give me this situation. Okay. And we're looking for undefined. Well, I'm actually going to put in the calculator and prove it to myself as well as let you see what to do and how to play with this. Okay. All right. So second sine. Okay. So we need 4 is M. So 4 divided by 3. 4 divided by 3. And press enter. Undefined. Okay, let's back out of it. Second mode. Then I went up, go up, highlight it, press enter to grab it. And then I put 3. I put 3 here. I go over, put 4, press enter, and it's valid. It gives me valid angle. Okay. And that's how I played around to prove it to myself. And D actually is the option. And if you look at your laws of sine and you know your basic trig identities, you can rationale that. You can push that out. You should know those items. Okay. All right. So let's look at number 6. A wire is connected from the top vertical telephone pole to a stake in the ground. Now that implies that it actually is on the ground. It touches the ground. Okay. The height of the telephone pole is 80 feet, and the angle of elevation of the wire is 36 inches. What is the length of the wire? Okay, let me draw this out for you. Okay, this is the stake in the ground. This is the top of the pole. Obviously, that's a pole, and we're going to say that it makes a right triangle. That it says vertical pole. They want you to think of that as implying that it's a right triangle. I really would rather that they have said that the pole and the ground create 90 degrees. That's the only thing that I don't like about this problem. Now, when you are taking a university practice test or an actual practice test, they're going to be very specific and they're going to say that. This is not exactly my favorite question, the way they asked it. I'm telling you, this is what they're implying. Okay. So we have 80 here. This is our 80 feet. When it says elevation, an angle of elevation, that means the angle should go up. And they're talking about the wire going up. This implies that that's where the 36 degrees goes. Okay. Now that wording is common, standard. Okay. So you do need to remember that. Okay. It's just that 90-degree business. I think they should have given you at least part of a sentence or a sentence simply stating that the vertical telephone pole creates or is perpendicular to the ground. That would have been highly helpful. Okay, now, but I'm off that soapbox. We'll move on. So, what could you do? I see two different ways to solve this. You can, because it's a 90-degree angle, you can use the laws of right angles as far as your trig sine, or you can apply your general laws of sine. Doesn't matter, those two will work absolutely fabulously. Okay, so let's use our trig identities, okay? So we have sine of 36 degrees would equal, now the wire here, that's our x or our hypotenuse. I'm going to call it x. So that's our x. So it's 80 opposite over r. That's our radius, we could say. It's our hypotenuse. Okay, so we need 80 over x. Okay, now what do we do? Well, we obviously need to multiply both sides by x. Okay, mark this out. And what are we really doing? Now, I'll rewrite it. Nah, let's use another color. Let's just take this. And now we divide both sides by sine of 36. Save myself a little bit of time. Okay. All right. Now, what do we really have here? Well, this goes away. This gives us x. And in the calculator, we need to put 80 over sine 36. Okay. All right. So I have 80 divide by sine of 36. Push enter. And okay, looks like we've lost one. Let me bring it back. Looks like something got pushed and we lost. There it is. Something got pushed and we lost one of our options, and it was our answer option. Okay, so it is D. Obviously, the others aren't going to work. Now, let's think this out. We have 80 feet. And as I said before, we are dealing with a right triangle, and these are the legs. Uh, two legs. 80 feet is a leg. It would be like your B if you had A, B, C, right? Okay, that means that R that we're looking for, the length of the wire, must be longer than 80. So we should have looked at A and said, that's crazy. That's impossible. It is not going to work, okay? And then we also know that 80 plus this leg. We're going to call it leg A because it looks like it's the smallest in my drawing. We're not sure of that. We're going to say that A, it might be larger, but we know that 80 and A together have to be greater than the hypotenuse, the R or the X, however we have it labeled. Okay. So, but we do know for a fact that the 74.04 100% can't work. Okay. So if you look at what we have, it makes sense. Okay. All right. Anyway, that gives us the last question in this video. And once again, I really appreciate you watching. I like it that I'm helping someone and you can benefit. We're going to keep going. We're going to give you more to watch over time. Okay. And thanks for the likes, the shares, and the subscriptions. You guys are all the best. Happy testing.